Hello guys, in this video we are gonna study how to solve to find the different psychrometric properties based on the dry bulb and wet bulb lectures that we have with our thin psychrometer. So we have this problem in which we, using our psychrometer, we find out that the temperature of the dry bulb temperature was 26 degrees and the wet bulb 21. The pressure that we have atmospheric pressure, and we are using this pressure in order to compare with the psychrometric chart. We are asked to find out the specific humidity, the relative humidity, the dew point temperature, and we are also going to find the enthalpy and the specific volume of air. Okay, so first of all, we are going to remember our relations from our adiabatic saturator. We recall that we have omega 2 to be where omega 2 is the exit of the saturator. So that will correspond to our wet bulb. Once that we have the humidity ratio at the exit, once that is saturated, we can compute and here state 1 correspond to dry bulb temperature. Remember that this was analyzed in the video, in the previous video where we studied the adiabatic saturator. So in order to get this, we need to find out, we need to recall that this PV, since it's saturated, will become pH2, Pg2. So it's the saturated vapor at state 2. So let's find out some of these properties. First of all, we're going to find state 2. We notice at 21 degrees. We have table A4. We interpolate between 20 and 25 in order to get our saturation pressure, HF, and HFG. We interpolate between 25 and 20 and 30 to get HFG2. HF2 to be 88, HFG2 to be, and we need also the PG2, which will be the saturation pressure at all of this from table A4. We need to interpolate. For state 1, we know that this is at 26 degrees, the dry bulb temperature, and the only thing that we need is HE1. Again, this is obtained by interpolation using data for table A. Okay, so first of all, let's get our humidity 2. These have units of kilograms of water per kilogram of dry air. With this data, we can get omega 1 to this value. So we have our first answer. With this value of humidity ratio, we can relate it to the vapor pressure. We recall that if we solve for PV1, and by substituting, this will be the vapor partial pressure for this mixture of air. Okay, so we have our partial pressure for air, and we need that partial pressure in order to get our relative humidity. So recall that relative humidity, we need to compute Pg1, which is the saturation pressure at 26 degrees. That is by interpolation, table A4. So we can get With our value of PB, we can also compute the dew point. So we recall that the dew point will be the saturation temperature at PB. This is our third value. For the enthalpy, we recall that we have two components, the enthalpy of dry air and the enthalpy of water. So this will be, we have all the data, so we can substitute. And if we solve it by parts, this value will be 26.13 kilojoules per kilogram. This part, the part that corresponds to the water, is 35.42. The total enthalpy will be 61.5 kilojoules per kilogram. That's our fourth result, and you can see that the energy that is associated with the water, even though it's a small amount, it's more than the one for the dry air. For the volume, we're going to use what we learned in gas mixtures, and we remember that the volume of air will be gas constant of air times the temperature of air in Kelvin divided by the partial pressure of air. So the partial pressure of air will be pressure minus vapor pressure. So this will be 100 minus PB. The partial pressure of air is 97.8144 kilopascal. And we know from table the gas constant of air. So substituting plus 273 to convert to Kelvin. So finally we got this value. This is the specific volume of air. With this we finish our problem. You can see that the results are the same. It's a very small variation. And it could be for the interpolation. Okay guys. Thank you. In a following video we're going to solve this same problem with a psychrometric chart. Thank you.